Welcome to YouTube. Okay. I don't know whether you noticed, Albert, but I pushed some start of some rotational patches.
Where? Where, Stuart? Oh, there?
Stuart.
Okay.
So we're working more than it is at the moment, but still far from actually, well, I've got one test example, but it's not passing.
It's really hard to understand you.
David, your Helio URL update, is that to fix all the endemic Travis fail?
Why Travis fail? Which one? 0.5.
No. Your URL update is to fix the other Travis fails, right?
I think so. I'm not sure the other. Probably that will fix part of it. I don't know if all of them, but yeah, I would say so. To do that also for 0.4, or we just leave it as it is?
We should probably backpatch it.
All right, so I will do now.
Seeing how it's ridiculously easy. Does anyone have any objections to 1080 before I merge it? Seeing how it's a one-line patch. So yeah, there's one HMI example that breaks that one HMI example I have that breaks that modified rotate function, and I don't really understand why. I haven't looked at it again, but all the submap tests that you put on your other PR, they work okay.
Wait, so I didn't catch that. Why is the HMI break?
No, it's not all HMI breaks. It's just I have one particular HMI file which it doesn't like.
Huh. Okay.
Also, there appears to be a problem with nans in the HMI file, which I can't remember whether HMI files in general, where if you rotate an HMI map with a nan in it, it would infect the whole image and just kill it. But that also happened in 0.4.
Right. I mean, that's not terribly surprising.
I can't remember whether I pushed the change that fixed that. Yes, I did. So I think this also fixes that as well. There's also a problem that if you do a scale operation on rotate in both 0.5 and 0.4, it breaks the WCS information. Because if you scale it, if you scale a submap, you're effectively moving the center pixel even further away from where you were.
Yeah.
So I haven't started trying to take that into account because I haven't fixed this properly yet.
Yeah, I would say that's a lower priority, but yeah. Yeah.
I wonder whether AstroPy WCS has any way of dealing with this.
Well, I mean, when you do the rotate and you redefine it to, if you redefine your reference pixel to be your center of rotation, then all you need for your scale is just to change your C belts, right?
Well, if you've rescaled the pixels of the image, because when you've effectively done the rescale first, you've moved your box. You not only have you changed the C delta, but you've also scaled your thing further away in pixel coordinates. I can't remember. No. Why is my internet? What is going on? Oh, I don't know. I can't remember. Maybe this has fixed it again. I can't remember.
Yeah, sure. I think there's some sequence you can probably do to make that actually do what you want. I'm not sure though. Okay.
Yeah, no, I don't know. Yeah, I can't. I need to have another look at it. Actually, I probably should get back on this. I don't know why the HMI example I have isn't working properly on this.
Stuart, I just tried my the first example from 2009, my original 0.4 PR. It doesn't work on your branch. What did you test this against? Yeah. The example
I'm sure I had this working. Damn it. I'm never going to get internet connection on this. back. Oh, script stuff working on some.
Yeah.
The other thing that Larry Manley mentioned to me the other day was that it isn't working if you feed it in rice compressed image data.
Wait, why is that the case? Shouldn't that just be unpacked at the PyFits, AstroPyFits level?
Something about it being integer and getting all upset.
Unreal. Okay.
Which is an easy fix. We just stick a forcible float conversion before we pass it to scikit image. But in theory, the scikit image routine works for integers, so I don't quite know why that's happening. But there we go. I did also, of course, in the process of doing this, discover another fantastic bug in SunPy, which is that submap doesn't work if the image is rotated, because our WCS pixel to world transformation doesn't take into account the rotate matrix. So if you take an AAA roll mover image and try and submap it, you get garbage.
Well, I mean, if you derotate it first, then presumably...
Yeah, then it'll work.
Right. Okay. I'm okay with that.
Well, that's part of one of the CC's GSOC project is to scrap our WCS pixel to world transformation and use AstroPys because they actually work. So hopefully we'll fix that before the next release anyway.
Sure.
This example works if I do it.
Well, that's weird. You're on your rotate_6 branch?
Yep.
Am I typing something in wrong?
Oh, okay. It doesn't work if I set the angle.
That's pretty important, yes.
Yeah, it's gone loopy again.
Okay, yeah. Get back on it, Stuart.
Okay. That'll be fun. Okay, I will try and fix that up when I get some time.
Yeah.
Other than that. Anyway, perhaps you could have a look over it and see if you can spot any glaring error.
Yeah, I'll try to. I'm really swamped here, but it might be a nice diversion.
Yeah, I mean, then it's
pretty crazy. I mean, I have just pulled most of your 0.4 code into that now, so it should hopefully, I would expect it to work perfectly fine, and quite a lot of the time it does, but...
Sure.
Okay, what I thought we could do seeing how Travis is currently up the wall, we can't really do a lot with pull requests anyway, is I thought we should take another look at our roadmap on the wiki. So, is everybody on this wiki page?
I am.
Can we? So 0.6 has some interesting things in it, as we appear to generally work on the principles which sort of wrap everything in the next release and then drop it back off. Albert's going for a walk.
Yeah.
So which of these things is actually going to get done into what does all of this even mean? What is this? Anyone know what this convert to NumPy standard for accessing data with image arrays is all about?
What did you say? Which one is what?
The convert to NumPy standard for accessing data in image arrays.
I think that refers to you remember that we are having like X and Y and whether we were using XY or YX or all the stuff. I think that refers to that.
I don't understand where in the library it applies. I vaguely remember this conversation, but not well enough.
It applies to all the functions that they were like convert, like all the WCS. They were like convert something to something. It was in like XY, but if you were going to use a map, you would have to use YX or something in that respect.
Okay.
I can find an example where I was using that.
Well, yeah, but I've always been of the opinion that we're supposed to abstract away the ND array access because that's our data storage container.
I vaguely remember when we had this conversation last time, we came to the conclusion that pixel coordinates should be YX and physical coordinates should be XY.
Yeah, all that is right. We have the discussion, but the thing is that we still have to implement it.
What?
Okay.
No, it doesn't seem to. I mean, I don't know who wrote this online item in the roadmap.
I think it's Steve. I'm not sure, but I'm going to take a guess.
It doesn't sound like what David is bringing up. It sounds like something more. I don't know.
Well, as far as I remember, I just made the connection, just trying to remember what I read with when we opened that page, like, or at least when we first discussed that thing and someone bring up that link. And I think it was because Steve and also myself, we had kind of a play with that, and we were having to change the coordinates, change the array. So when you were having a list of arrays like x, y, if you want to use it, you have to transverse them. So we could use y, x instead, which for me was fine, but it was not clear at first how to do it or what was the right way to do it.
You know, this roadmap would be a lot better if it linked to issues, where we could actually discuss it then. So like these single phrases can actually be fleshed out more. And also the difficulty behind implementing each of these.
Last 10.
Also, they shouldn't really be used as like a general feature wish list.
Right. It should be the other way, basically. We use the issues, and then we pull issues into this to say, okay, this issue would be treated by this roadmap, by this release. Rather, the GitHub issues would be our wish list. And as we identify items that are, on the horizon, or we have people that are going to be implementing them, and then we can move them to the roadmap.
Also, the roadmap is like major components that link together to get us to like 1.0 and beyond. So.
Sure. Yeah.
Okay. Refresh the page. I've had a bit of a fiddle with it.
Stuart, that AstroPy quantities item.
Sorry, say that again.
That AstroPy quantities item under 0.5, shouldn't that be bumped down? I mean, we're not done with that, right?
Yeah.
I mean, technically, I don't think there should be a 0.5 section on this roadmap anymore, anyway, right?
Indeed, that can go away. It's horrifically outdated. I updated it again.
Okay.
So, our 0.7 release is going to be another non-JSON release like 0.5. So, what are the core things that we as the development team are willing to put time into in 0.7? Because big features we're not going to have outside input, so any big features in 0.7 are going to need to be built by us, basically. Is someone willing to pick up the AstroPy time bit, or are we going to leave that and make it part of a GSOC project? Is it going to be a whole GSOC project for next year, or...?
I really cannot understand like 80% of what you're saying, Stuart.
Same here to be truthful.
I'm sorry. I need a bill cancelling microphone.
It is World Cup time.
As you might be able to see in the background.
Yeah.
Is one of us going to pick up the AstroPy time bit and work on the AstroPy time stuff for 0.7? Or shall we make a GSOC project out of it for next year? Do you think it warrants a whole GSOC project on its own?
What's the timing for 0.7?
So this time next year, May next year.
I don't know if it's a whole GSOC project, but it might be like half of one. And you figure out what the other half is.
Yeah, I think that would be wise. Or wait till then, maybe in that time some of us manage to get a hint of it.
So, what are the next major things that people can think of that they feel that SunPy needs to do? Can anyone think of like, yes, yeah, very good. But like big features that I'm talking like fundamental cornerstones of the library kind of thing. Or like solar physicists need in life in general we don't currently have.
Well, for my part, I would desperately need spectral fitting, whether that belongs within SunPy or is an affiliated library, of course, that's still whatever. But
what do you describe that a little more?
X-ray spectral fitting or UV spectral fitting?
X-ray, for me. X-rays and gamma rays. So I need to be able to fit lines, fit spectral components, and presumably also pass that through a response matrix for converting photons to counts, or detector response matrices. So I mean, that's what I need to do, kind of my kind of science in SunPy. But again, whether that belongs in core SunPy is questionable.
Well, and I'm having the same. Sorry. I'm having the same kind of a doubt now with ICE and with Mateo, whether we need that as part of interface in SunPy, because many of the spectral fitting we can do with tools that are already in AstroPy or with SciPy, just by fitting lines. So where do you think that this is what we need?
I wonder, have you looked into AstroPy affiliated packages for spectral fitting? Because I know there's quite a lot of like early stage work going on in various.
Well, I'm sure AstroPy. I'm sure there's people pushing along the same lines. No, I have not.
What like data structures would you need to enable that kind of workflow?
I think possibly the most interesting thing to talk about is spectral response, the detector response. How exactly that would exist as an entity in SunPy or in something else. Namely, how do you convert from photons to data number, to counts, to whatever? Usually, you want that. We talk about it in the way we've handled in SunPy, where we try to get back to the physical unit, or we use data that's already calibrated. But when you do, sophisticated spectral fitting, you always want to fit to the raw data, and so you need to forward fit through your response, and so that should be carried inside as a Python object of some type, and you can envision a fair amount of metadata associated with a response matrix as well, the very particular circumstances that response matrix is applicable for, and how that response matrix might be parameterized and be adjustable. A parameterized response matrix of some type. I don't know. That's just what I'm thinking.
To my mind, well, certainly currently, the scope of SunPy is high-level process data.
Right.
To my mind, I quite like the idea of it staying that way.
Yeah, the challenge that I see for that, in the way I just described it here, is even if spectral fitting were an affiliated package, in some sense, I want access back to the lower level stuff. And so SunPy, at some level, would need to still make that available, even if that's not as, the way that it's not the pretty way to look at the data or something like that,
Would you mean like store both unprocessed and processed data, or just store a whole history metadata set?
Well, I mean, if we could do, I don't know how much has been discussed in a broader, but certainly Steve and I have talked about, if you could always store just the rawest data, or mostly raw data, and then do, non-destructive manipulation of the data and store that history. That would be awesome.
That is something that Nadia Derchler at Space Telescope is kind of working on. In that is very much falls within the scope of the generalized WCS framework. Sure. I can forward you an email conversation that I've been having with her about that. It's gone quite. What that does is it strings together a set of AstroPy models on a transformation graph like the coordinates one. I mean, you're talking about images, though, right? You're talking about spectral images.
Me? No, I'm talking about pure spectra.
We already have a 1D spectrum of the.
Right, but well, yes. Okay, so part of what I'm thinking goes beyond the scope of SunPy almost certainly, in the sense that you want to have spectral components, and the spectral components that generally people worry about in solar are not necessarily the same as in astrophysics when we're talking about fitting flares, and they are not just Gaussians, for example. So, and then the extra complication is you can't often fit just straight Gaussians to data that's in count space because they don't actually look like Gaussians. And so the whole, I haven't looked at what SunPy is doing. Like I said, I'm sure, especially the higher energy astro people would be having lots of the same concerns as I would in terms of how we would actually do data analysis, or same interests, I should say, not concerns. So no doubt there's motion on that side, but yeah, I'm not entirely sure exactly what I would want out of core SunPy to make sure that's enabled.
Should we make some kind of a document with the workflow, so you could expose the X-ray workflow, like what kind of fitting exactly, because kind of a snapshot of the steps, and I will do the same for the UV, and then we can decide from there, like check out which part can be done by SunPy, which parts can be done by other packages, and try to get a better view of how that will, which things will fill most of solar people needs.
Well, if you want to get the ball rolling on that, David, sure.
Well, I can start with the EUV because that's the one that I know.
Yeah.
And kind of I still don't get where the line separates between what we do in SunPy or what we can do with SciPy, for example. So, and I'm planning to do that anyway, to discuss it with Matteo and see what our next steps. But I would like to make it, or to plan it beforehand, so we can aim for the most general case, and then let the individual case just to each one of us. So, like if there's something very particular about X-ray, as you were saying, and count, so maybe we could just look that on a side, and then put them, just the general parts on together. Like the spectra part now in SunPy is not actually a real spectra; it's just a number of counts versus a wavelength or frequency, or even it could be even time frequency in the other axis. So it's not the same thing that we were like having in X-ray or in UV.
Mm-hmm.
Well, I guess I will try to make some kind of document during the next weeks in the wiki, and then
Sure.
I just have to add stuff there.
Is Andy there? Andy, you do analysis. What do you want?
Hello, I'm here. Analysis. Yes. Sorry, somebody came into my office, so I missed a bit of that. You're talking about the roadmap, what we really want SunPy for the next few iterations, right?
Yeah. What would make SunPy useful for you?
Well, I agree with you that spectral analysis spectral fitting will be very important. That's something that we haven't, well, we've thought about obviously, but we haven't developed fully. Well, I would say that something that we don't have yet and we will need to have in the future is more instrument-specific tools. But then again, of course, that leads to the same question of whether those should be core SunPy or something affiliated or elsewhere or what, so that we can maybe process raw data or just have convenience tools for all the individual instruments that we have in the Heliophysics Observatory system, whatever it's called. And we don't have that many of those yet.
Yeah, I don't know. I like the idea that SunPy is a process data library.
Well, that's what it was.
In that we keep it to high-level calibrated data, and then calibration pipelines go in separate packages.
You going as well?
Yeah. I've made it up.
I mean, I don't really. Sorry, go ahead, Albert.
Well, so the part of the question there is when you're talking about an X-ray and gamma ray world, it's not something that that calibrated data doesn't necessarily mean that you can bring it back out to photon fluxes as a unit, because you can't, unlike other energy regimes, you can't just invert your response. You can't say you had this, this many counts, and that means you had this much flux in that energy bin or something like that. You really have to. It can be a very ugly one-directional thing. So you can't bring it back to a high level where you can say, okay, this is the photon spectrum from RESI. This is the photon spectrum from Fermi, and then just compare them just at a high level way. Normally, when we look at something like RESI data or Fermi data, or most of the time when we look at something like that in the X-ray gamma ray regime, you show it in an instrument-specific counts way, but you work with the data, you analyze the data, where when you fit it, you take a photon model, you fold it through the same thing, you put it into count space, and then you compare that with your data. So in some sense, the calibrated data that you look at when you're in X-ray and gamma ray regimes still has units of counts. They're good counts. They're counts you really believe. They're calibrated counts. But they're still counts. They're still not a physical unit. And so when SunPy wants to plot a RESI gamma ray spectrum, it's going to not be in physical units. And whether we're, I guess, happy with that or how we want to treat that, I don't know. And that's part of the discussion. It's different from what we can do in the EUV and the optical in terms of sticking with high-level physical units.
When I say high-level calibrating, I don't necessarily mean physical units. I just mean I don't see that calibration pipelines for different instruments should live in core SunPy.
Oh, okay. Well, sure.
Because then we end up in a SolarSoft situation where you have one package that doesn't prove in everything.
I mean, that's still, finding that balance is still something we have to do. Okay, I need to take off, so I'll talk to you guys later.
Okay, cool. David, how is the ICE data stuff coming along?
I think it's pretty good. I'm supposed to test it. I was supposed to test it today, but I have a course to do. So, for what I see there, it looks nice. And what I talked with Mateo, it looks also. He knows what he wants to do, or he goes in the right track, better say.
The problem I have with that work in general, not specifically what he's been doing, but in general, is the problem is that while it scratches the ICE itch quite nicely, it is so not scalable it hurts. So we have load of 3D spectral data. Scalable. We have load of 3D spectral data here, but it's all time series. So we need a 4D cube object.
Yeah.
We need
you mean like
we need some kind of general way of handling all of this.
Yeah, I don't know. It's going to be so straightforward. It depends on the structure of the FITS files, because the ones you're talking about, like the spectroparameters, you have 4 different images in the same file.
No, they'll see. No, to my mind, they'll
Well,
manage. You take
yeah, well,
those.
it depends. Okay.
You saw my comment on the GitHub thing because
Yeah, but
we shouldn't
it's
have
kind
to.
of
We shouldn't have to. We need to abstract the concept of the data types away from the actual data in some respects. So the FITS file, the way the FITS file is laid out has got nothing to do with the data types that we implement.
right. And in a way, the cube should be instrument independent.
Yeah.
And we will have a parser that it converts the ACE data into that cube.
Yeah.
Yeah,
Which
that's
is
right.
kind of the way that
Mateo.
our io.fits is set up already is like that. It assumes every HDU inside the FITS file is separate.
Yeah.
So if you implemented a spectral cube factory that takes in a FITS file, it would spew out a list of cubes.
Exactly.
Which is the correct behavior.
Yeah.
What I was saying is that yes, for a 3D spectral cube one time step with a wavelength component, that ICE data project is working on is great. But we also have need for a we also have need for a 4D object where you have x, y, lambda, t. And we also probably have need. We also have need for a 3D object which is x, y, t.
Yeah.
My point is that we shouldn't need different objects for every of these. We should have one object that can do the lot.
I agree with that. But the thing is that, well, in part, I think that we need examples on the different kind of files because, yeah, to be able to play with them and see how we do all the stuff. And the problem is, like, on my side, just like I understand just the spectrograph as ACE or CDS or Summer. The spectrograph, spectropolarimeters that have this kind of similar structure, I haven't used them all, so I don't really know or have the sources to compare them and guide in that respect. But yeah, definitely, I'm completely agreeing with you in the sense that the factory should be kind of independent. But I see that as a first step, as when the first step that we were doing maps and then checking out how to put in the bigger, get the bigger picture with the other ones.
Yeah, I don't know. I mean, the thing is we need to come up with a way of dealing with that in a generalized fashion before it spirals wildly out of control. Because I think we're at the point, unfortunately, we seem to be at a crossroads where we have people wanting to use SunPy for ICE data or 4D data cubes or all manner of different things. But to scratch each one of those itches, we're going to create a new blooming data type. And the problem is
we
that
have to beat our rate.
the problem is the upstream AstroPy tools aren't really there. The AstroPy tools are not in place to create the generalized object that I dream of.
Then we just wait and help to the dream.
I just don't want to implement all these separate objects in the meantime. Because we're going to get laden with a ton of backwards compatibility objects.
No, we could write that in our guidelines, in here, saying we are not going to do that. If we are going to doing something, is for testing purposes or something like that. But that's. I mean, in that pull request, like what he's doing, we can just hold in there and just making it work in a better way.
Yeah, it's something I need to think about anyway.
Hopefully, it doesn't go that long like the hypercube, but
I am wondering whether restarting Hypermap is a good idea.
well, probably you learn something from that.
Yeah, I learned that it was massively complicated.
That's something.
I don't know. Okay, well, unless anybody else has anything to add, I think we've had some interesting
Well,
discussion.
I'm going to. Dan wrote an email about what we think, or where our limits of SunPy is regarding his code. And I was just waiting to see if someone answered, but no one answered yet. So I'm going to put my comments there. I think that Dan wrote a bit of it. But the thing is that whether his code or his calibration algorithm should be part of SunPy or not, I see points in favor and against it. In favor is that there hasn't been any code done in the 30 years. Against it is like it's his code, and like he has his own publication on that, and in a way I suggest that he will have it in an independent repository to help him or to obligate him in a way to keep it up to date. But yeah, but I will try to write that in a longer email and with an example or something.
Was that an issue, David, or just an email?
No, he sent an email.
Email,
It's a discussion that we have an ERC like a couple of weeks ago, and he sent it last week.
Yeah, I remember now you mentioned it.
But in the ERC chat, we were having like I was telling him why it looks good or why it shouldn't look good. In a way, like if no one has ever done that, the only I'm only just afraid on the sense that people will think that that's the official thing from Ghost or whatever, where it is just how he has done it. Now on the other side, if what am I gonna say? Like if he has like the code there and gets outdated and he never changed it, maybe no one will change it. Now his only problem, or he doesn't want he wants to make it easier for the user. That's his point. So he think that making the user to install 3 different packages it's a problem. I think it might be, but Pip is coming better and better. So I would not make that as a problem. So that's where I would say as an affiliate package would be better, or some kind of other installation method that if you are going to use it, you just pop up some kind of warning and say, well, you need to install this thing first. It's the same thing that we discussed like a few months ago.
Right. I mean, I think I know where he's coming from in the sense that as a user, you kind of want to like install one thing and then like, oh, this is great. I've got all the tools I need. So, but on the other hand, you could set up something to make package installation very easy.
That's not the way that Python works, though. Install one package and have everything you need. It's not the way the ecosystem works.
I understand that, but I mean, like in SunPy, if we set up a mechanism to make it very easy to get the affiliated packages as you needed them, that would be useful, right?
Yeah. And in theory, it should be. Like, it should be quite easy to do that because you can just pip install that package. Or for more complicated systems, if we're in the future with Anaconda, you can just Conda install that and you can provide compiled binaries for it, and it should be really straightforward. So
Yeah.
I have hope for that in the future, and I don't think that the limitations of Python packaging should influence our design decisions.
I have another question on that front, though. If we start taking stuff out of SunPy and let's say put it in an affiliated package, are we going to have problems with testing? So when we then change something in SunPy, you might break the affiliated package, and would your testing show up any of that? You know, I don't know how that would work.
Well, yeah, that would be up to the affiliated packages to deal with.
Yeah, my worry is that wouldn't. A lot of them might, it wouldn't work so well, right? If somebody writes their package and then never updates it, no. Whereas if it was in SunPy, you would know that it was broken.
But the thing is that the affiliated packages would have to work, give or take, on major releases or releases.
Yeah.
Because you can't keep all the affiliated packages like up on master permanently, like we do, like because of the point you're making. It's very difficult to do that unless they're being like actively developed. Unlike people are on them as much as they are on SunPy, then you just set up a Travis test to test your affiliated package against master.
Right. Yeah, I was just wondering how, in practice, how that would go. Let's say Dan writes his TEBS affiliated package, publishes it, work with SunPy 0.6 or whatever, but then we publish 0.7 and it breaks. It's like up to him to fix it. And
yeah, in theory, if he's on the ball, he should notice it's broken before we release the next version.
Yes.
And either cry bloody murder to us on the main repo or fix his code.
Yes, in theory, yeah, exactly. I just wonder how.
I mean, in practice, unless SunPy core say this affiliated package we are also maintaining, we are babysitting this, and we will make sure that this works all the time, and then we add it to our Travis matrix, and we make sure that always works. That's the only way that we could do it, but we can't obviously do that for every affiliated package that's managed and developed by external parties.
Yeah, I guess you're right. Yeah.
We have to adopt if there is one that's like fundamental to the way we're doing things, but yet for some reason isn't in core SunPy, we could adopt it and make it like special.
Yeah, I guess
or something. But
no, you're right. I guess what we could maybe have then is I'm just thinking about the future is a person who's responsible for keeping in touch with affiliated package managers. So like, let's say call him a communications person for lack of a better term. I'm like, so you know who the package manager of TEBS is? You know it's Dan Ryan. You know that SunPy is being updated. And you say, well, look, you keep in touch with them. Say we're making these changes. Have a look at your package, see if it's still compatible, and it's a two-way thing, right? You need somebody to keep in touch with all the affiliated package managers.
Yeah, I agree, but I mean, sure, in the future with lots of big affiliated packages, maybe lots of instrument pipeline stuff, something like that is definitely a good idea. But I still feel the burden of responsibility is the other way around, in that it's up to the affiliated package people to keep up to date with what's going on in the main library. And but, in many ways, they should be core developers of the main, well, not necessarily core developers, but certainly active developers of the main library as well. If they've got tons of code that's relying on our code, they should be contributing to it and working on it quite a lot anyway.
Yeah, I don't disagree with any of that. I'd just say that, by helping them, we help ourselves too. So
yeah, definitely. No, I'm not disagreeing. Saying there is a practical limit to how far we can babysit affiliated package developers.
Yeah.
Because we only have so much time. In my case, approximately 0 and reducing. So,
yeah, sure, absolutely.
secret. I haven't really read Dan's SunPy depth in.
I mean, I actually don't think one of his points was that in SSW you get everything you want first time round, but I actually think that's not. It's not really accurate because when you install SSW, okay, you get to choose your packages, but you then may find that you want some other ones later, and then you have to go and install those separately, just like you would in SunPy. Right. So it's really the same. It's very similar. And that happens to me a lot, where I realize there's a SSW package I don't have, and okay, it's easy to install the next one, but it would be easy in SunPy too. Or I mean in Python too. So I'm not sure I agree that that's different.
No. SolarSoft is modular.
Yeah.
In theory, but as with everything in SolarSoft, there's a lot of things in theory in SolarSoft, and practice can be quite different.
Yes, you're right. I mean, yeah, there's a lot of interdependencies within all those modules and stuff. But he was one of his arguments was that our system would be less convenient than the SSW model, but really I think it's the same model pretty much.
Yeah.
Anyway.
I think it's an interesting question because in all of our discussions about affiliated packages and all that sort of stuff that we've had up to this point, we have been considering primarily instrument pipeline code and instrument-specific calibration code or instrument-specific this, that, or the other. Whereas what Dan's talking about and what's cropped up in other places in the last few months is physical analysis code.
Yeah.
And we haven't really discussed that very much. What we're going to do with physical analysis code, and where do we draw the line where it becomes its own thing as opposed to being part of SunPy, which is really currently at least, it's a very data-focused library. It's for getting in data, munching data, giving the users access to data in a standardized, uniform manner.
Yeah. Yeah, I think we'll have to discuss that more because there's going to be more and more of that, I guess. Physical analysis stuff coming later.
My gut feeling on that is to some extent it belongs in the main library as long as it doesn't get too out of hand.
Yeah. Yeah, I sort of agree with you. My first thought.
I do wonder whether this TEBS thing belongs inside of SunPy or not. What did you think in the end, David, that you were chatting to him? Did you come to a conclusion in your own head?
Well, the good point of having inside SunPy is because it hasn't been done in 30 years. No one has done anything.
That's not a good point of having it in SunPy. That's a good point of writing it in Python.
Yeah, no. Well, in ideal either. This calibration, it seems like hasn't been done at all. Like those people never come across to do it in that way. I don't know if there's another way to doing it, but it seems it hasn't been done. And that's Dan's point. Like to say, it's not it won't change in that respect, and it will just change the number of the new satellite whenever the new satellite is up there. In that respect, I mean, it's a calibration thing that it should be part of SunPy in that way. In the other way, I think it will be better for Dan having it as a package under his own his own repository, and that will give him name as the people who will be using it, and that will give him the obligation of supporting it or of maintaining it. Maybe it doesn't. He says, well, it won't need any maintenance. I doubt that from any software, but having it under SunPy, it may open the doors to other people to bring other codes. It will open the door to say, oh, why now my code that detects whatever, or it just calibrates this in a fancy way, why cannot be here as well? So that's my bigger door. Or
there's another interesting aside to this, in that Drew is working on a SDO DEM code in Python, which is basically his PhD project.
Yeah, that would be something similar. Like there is also from another one from what's this guy?
Marcus Ashwanden.
Yeah, Ashwanden, which is, have you seen the ideal code?
Yeah.
I haven't. No.
Yeah, I've seen it.
Okay, don't do it.
I don't want to go
Anyway.
there. I don't like viciously torturing myself for no reason.
So it will be more than one code that does that thing.
My point is that is something like a DEM code in SunPy something that we want in core SunPy?
I think I would put that as an affiliate package.
Really? That's interesting.
I
have the opposite opinion.
Well, in the way that you have more than one way to do it. If there is only one way to do it, and that's some kind of an official thing, and everyone follows that, then I would put it in SunPy. At the moment that you have multiple ways to doing it, I don't know. Because it could float. That's my point. It could just people from Glasgow will have one. People from Montana will have one. People from Belgium will have another one.
The point of putting it in SunPy though is that you get everybody working off the same code base to some extent, and that you don't have to reinvent the wheel every time. But I agree that if there are different physical algorithms for doing it, then it becomes an interesting problem. But the DEM thing, there isn't. At the end of the day, there's only. It is the same physical problem you're solving. How many different ways to do it are there?
Well, there's a few, and they're non-unique as well. Is the problem. The answers you get non-unique. So I sort of agree with what David was saying. Like, there's multiple answers you could get out, and you want to have a situation where, like, people think that something's official because it's in SunPy. Like, this is the correct answer because it's in SunPy. Where in reality, everyone's got their own method, and you're getting lots of different results. That's something to think about.
The problem is if we set this affiliated package bar too low, then it's going to become ridiculous. But there are going to be hundreds of them.
Well, I think that the affiliated packages need also like a kind of a control as well, and some kind of as you say, we are not going to reinvent the wheel. So if something is done in one, or if something is done in SunPy, the affiliated package should use what is done in SunPy and then build on that. It's not just completely build the whole reading file, fixed file, and all that stuff, So, but also it should have some kind of control or classification. So maybe we can have a single package which contains all the DEMs. Single package which contains all the.
But does having many different DEM codes inside core SunPy, is that a problem?
I don't think it's a problem. My only problem is, like as Andrew say, when the people start to assume, oh, it's in SunPy, is it true? And I've seen that in IDL. People say, oh, this problem give me that, or this program, which I don't know, is DEM calculation. And then, but you know who did that? Do you trust what is done? People kind of don't go into it. Just run the problem and write a paper and put it there. And I've seen that with wavelets. I've seen that with many other stuff. And it's like, no, that's wrong.
It is a good
So
point.
I don't want.
I don't
want to put
think
some
that's a point that we can. I don't think that problem is necessarily addressed by the affiliated package model, because someone will just download the affiliated package and shoot and destroy it.
That's right, but it will make them an extra effort to get to that place. And they should have their documentation by themselves. So if the people doesn't want to document the code, I mean, it doesn't matter if it's an affiliate package or just a repository anywhere. But at least they will have to go into that problem, that thing. So that of course, if people will be able to use it wrongly, but just making the people more aware that there's different things. So there's a SunPy, is a core, and then you have other thing which is will do something else. It will make the people the brain more modular in a way.
I just wonder whether it will make it a bit too modular. But I suppose that really comes down to it. That really depends on how easy it is to install the components.
Yeah, there's got to be a balance here somewhere.
Because, I mean, you need build time again, come back to needing money and build time. Because we could maintain binary build versions of all the accepted affiliated packages on Binstar, which means that if you were using Anaconda, you could just install them straight off, no problem. And it should all just work, because we have a set of compiled packages that we're linking against at all times, and it just behaves itself. So I reckon that Anaconda is actually the solution to all the problems. I really do think that Anaconda and Conda specifically are the solution to all the problems. It's just a matter of time.
Yeah. Well, it looks like we lost our audience here.
I mean, it's not the answer to all the problems, because there are fundamental limits to Anaconda in that it statically links within itself, so it doesn't use any system libraries, which has its advantages. But also, I've run into problems with HPC on doing my research work, where I wanted to use Anaconda, but I couldn't because it didn't use the cluster's MPI library, for instance. So when I say it's the solution to all the problems, I don't really mean it's just the solution to a lot of them. From a normal end user on your laptop kind of point of view, I think it's very much, it makes life so much easier.
Oh, I absolutely agree. I use Anaconda for everything.
I use Anaconda for nothing. I don't actually use it. So.
Well, on the Mac, I think it's easily the easiest way to do Python stuff.
Yeah. But there again, I don't use a Mac, and never will.
All right. Well, maybe we should wrap up for now.
It's something to think about anyway.
We should discuss that in the
keep discussing it until we come to us. The problem is, I don't think we can honestly solve this. We're going to have to find the lesser of two evils and come to an answer. But any sort of document we draw up specifying what belongs in the library and what doesn't will be challenged every time. Why doesn't this belong in the library for this reason, and that reason?
Yeah, it may end up being a bit more case by case than we would like.
And over time, the line is going to get very blurry. And it's really, I don't know.
Yeah, we might just have to deal with an imperfect system.
Well, little and little, we don't have to solve all the problems at the beginning.
Yeah.
If there's a point that the line disappears, then the line disappears. But if we can manage to teach the people in that way, just to get the things right at the beginning, maybe in the future it gets better.
I think we're
not going to use Python. We're going to use Platlan.
All hail Julia, the answer to all our problems. Okay, all right. If anyone can think of anything else to add, if you're a YouTube person, if you think of anything else to add to the roadmap, then stick it on there. But try and keep it sort of big, blocky steps.
Yep.
Yeah. Okay.
All right. Speak to you later.
Today. Bye.
All right. Thanks, guys.
You're right, just to show you are leaving Worship. Actually,
Thanks.
Richard, you can hang around for a second and I'll help you with the rebasing stuff.